Section 1, Introduction to Exponents. Number 1, how many squares do you see in the image below? When you look at it, you might see 4 here, and then another set of 4, and another set of 4. 1, 2, 3, 4, 5, 6 sets of those 4 columns. Each of these chunks has 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 and 4. That's 4 times 8. So there's 32 here. And then 1, 2, 3, 4, 5, 6 of them. So 32 times 6. So whatever 32 times 6 is, that's how many squares are in there. You may also just count all the way down and get 8. And then 4, 4, 4, 4, 4, 4. 6 sets of 4 is 24. So 8 by 24. That's also how many there are. Whatever method you use, these are both the same. There are others as well. You can find that there are 192 squares in the image below. Counting the squares above is an easier task for an older student than it is for, say, a 5-year-old child. To a kindergartner, the likely way to approach the task above is by counting 1 square at a time. 1, 2, 3, 4, etc., 27, 28, 29, and so on. Fortunately, you don't need to count like this anymore. At some point, you learned how to speed up the tedious task of counting by combining groups of numbers and counting those groups multiple times, hence the word multiplication. For example, 4 plus 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 4 can be expressed as 8 sets of 4, or 8 times 4. Multiplication is a way to express repeated addition. Number 2, consider an example of another repeated operation. You'll need a spare sheet of paper. I have one right here. And I think you should grab one too. You could just listen and think about it or imagine it, but if you have a piece of paper, grab one. Part A, take a sheet of paper and fold the paper in half once. When you unfold it, the paper will be divided into how many sections? I unfold mine, I see 2 sections. Part B, fold the paper in half once again. Now fold that portion in half, and then fold this entire portion in half a third time. When you open it up, the paper will be divided into how many sections? I see 8. 8 sections. So 3 folds leads to 8 sections. Part C. If you fold a sheet of paper in half 5 times and open it up again, into how many sections will the paper be divided? Well, you could do this. 1, 2, 3, 4, 5. Now when I open up my piece of paper, I see 4 chunks going one direction, and 2, 4, 6, 8 chunks going the other direction. 4 by 8 is 32, so I see 32. Number 3, you should now notice a pattern in the growth in the number of sections as the paper is folded. Part A, a sheet of paper will be divided into 64 sections if you fold it in half how many times? Well, to answer this question, let's look at what happened when we folded the sheet of paper once. I'll make 2 columns here. 1 fold, and then we had how many sections? There were 2. If I had 3 folds, there were 8 sections. If I had 5 folds, there were 32 sections. Well, you might realize, or you may not, but I'll go ahead and show you that if there were 2 folds, there would be 4 sections. Going from 2 to 4 is doubling, from 4 to 8 is doubling. So if there were 4 folds, then we would have 8 times 2, or 16 sections. And we see now, if we continue that pattern, 16 times 2 is 32, so 5 folds makes 32 sections. If we want 64 sections, then let's go to our table and imagine building up from where we are. 32 times 2 would be 64. So that would be the next one after 5, which is 6. So folding it in half 6 times. Part B, a sheet of paper will be divided into 256 sections. If you fold it in half, well, let's go on my table. 64 times 2 is 128. That's 7. 128 times 2 would be 256. So 8 folds would be 256 sections. Number 4, if you fold a sheet of paper in half n times and open it up again, into how many sections will the paper be divided? Let's look at all these numbers here. 1 went with 2, and then 2 goes with 4. Well, 2 to the second power is 4. 2 to the third power is 8. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2, or 2 to the 4th power, is 16. So if there are n folds, we will have 2 to the n sections that the paper is divided into. And there you see we can use an exponent to show repeatedly multiplying by 2 in a condensed form. If you could fold a sheet of paper in half 10 times and open it up again, it would be divided into 2 times 2 times 2 times 2 times 2, 10 of those 2's sections. If you could fold it in half 75 times and open it again, it would be divided into ... As with the squares earlier, this is getting rather tedious again without more condensed notation. Number 5. Since 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3 can be expressed in a more concise form as 3 times 7, how can you express all of these 2's in a more concise form? That is 10 2's, so we can write 2 to the 10th. Just as multiplication represents repeated addition, an exponent is a type of notation that is used to represent repeated multiplication. An exponent can be used to write all of these 2's in a much more condensed form as 2 to the 10th, or 2 raised to the 10th power. Number 6, write each of the following expressions as a single number raised to an exponent. Part A, 5 times 5 times 5. There are 3 of them, so 5 to the 3rd power. Part B, there are 4 10's. Multiplied together, that's 10 to the 4th. Part C, there are 5 negative 3's multiplied together, so I'll use parentheses and write negative 3 in parentheses to the 5th power. Number 7, write each of the following expressions as a single variable raised to an exponent. Part A, there are 3 x's multiplied together. That is x to the 3rd power, or x cubed. Part B, there are 4 y's multiplied together, so that's y to the 4th. Part C, there are 5 z's, so z to the 5th power. Number 8, write each of the following expressions as a repeated multiplication expression. For example, 7 to the 3rd can be written as 7 times 7 times 7. Part A, 10 to the 3rd, 10 times 10 times 10. Part B, negative 2 to the 4th, negative 2, and I'll use parentheses, times negative 2 times negative 2 times negative 2, 4 of them. Part C, m to the 5th, m times m times m times m times m. There are 5 of them. Number 9, write each of the following expressions as a repeated multiplication expression. For example, 7 to the 3rd can be written as 7 times 7 times 7. Part A, 3 to the 3rd times 3 to the 2nd. 3 to the 3rd is 3 times 3 times 3, and then I'll bring down a dot for multiplication. 3 to the 2nd is 2 more 3's. That's 5 3's in a row. We're just going to leave it out like that. Part B, y to the 3rd times y to the 2nd times y. Y to the 3rd would be 3 y's multiplied, times y to the 2nd is 2 more, and then times another y. So we have 6 y's multiplied together. Number 10, how would you write 2x to the 4th as a repeated multiplication expression? Well, I would start with the 2x in parentheses, and then write another 2x, and then another 2x, and another one. You could use dots, you could use other multiplication symbols, but I'll use parentheses for now. Number 11, how would you write x plus 1 squared as a repeated multiplication expression? With parentheses, we can put x plus 1 in parentheses, and then parentheses x plus 1 again. And that indicates multiplication when you put the parentheses next to each other like that with nothing between them. So x plus 1 times x plus 1 is x plus 1 squared.